All right, welcome everybody. Today we're going to be talking about chapter 1 in our textbook. It's all about defining matter, what is an atom, what is an element, what is a compound, and talking about introducing chemical formulas. So chemistry is broadly the study of matter. Matter is anything that has mass and occupies space. And we usually just think of mass as the amount of matter that's present. So here on Earth, we just think of mass typically as the weight of something. But technically, mass does not depend on gravity. So mass is actually a constant. So let's say your mass is 10 kilograms on Earth, your mass would also be 10 kilograms on the moon. However, your weight on Earth would be different than your weight on the moon because gravity is different on Earth and on the moon. So mass is constant. It's the amount of matter that a substance occupies, versus weight depends on gravity, so it will change from place to place. So let's define matter. Matter includes all natural, living, and non-living things, seen or unseen. So things like plants, animals, rocks, soil, bacteria, viruses, or other microorganisms. It also includes synthetic materials produced through technology. So you might be thinking, all right, that's basically everything. So what does matter not include? Matter doesn't include various forms of energy. So like heat, light, and electricity. If you think of these things, do they occupy space and have mass? No, not really. Heat, light, and electricity, they don't occupy any space. They don't have any mass. So those forms of energy are not included as matter. But in chemistry, nearly all changes of matter, which is what we study as chemists, involve energy in some way or another. Like to get a chemical reaction to occur, to change one substance into another substance. That's a change in matter, so we study that in chemistry. And in order to do that change, it usually takes some energy. And so really chemistry is the study of not only matter, but because we change matter as chemists, we also study the energy that's required to make those changes. So in chemistry, you get to study virtually everything, which is awesome. So we can define matter by its physical state, also called its phase. So there's 3 physical states of matter: solid, liquid, and gas. In a solid, the matter has a definite shape and a definite volume. So if you think of something like a penny is solid. It keeps its shape and it keeps its same volume, no matter what container you put it in. A liquid has indefinite shape, meaning it will form to whatever shape container you put it in, but its volume will stay the same. And then gases have both indefinite shape, so they'll take on the shape of any container you put them in, and they have indefinite volume. And this means that the gas molecules are going to spread out as much as they can to fill up whatever container you put them in. So solids, definite shape and definite volume. They keep their shape, they keep their volume. Liquids will change their shape, but they keep their volume. And then gases will change their shape as well as their volume depending on the container they're put inside. In addition to defining matter by the physical states, we can talk about matter in terms of the properties of the matter. So there's 2 general classifications of the properties of matter. There's physical properties and chemical properties. So a physical property describes the physical characteristics of a substance. These are properties that can be observed without changing the identity of the substance. So things like texture, hardness, odor, the physical state or phase at a specified temperature, the melting or freezing point, at what temperature does a substance melt or freeze, the boiling point, at what temperature does it convert from a liquid into a gas. Is it ductile, which means can you stretch it, like stretching a metal into thin wires? Is it malleable, like is it bendy? These are all physical properties. And I kind of think of the physical senses or 5 senses. And if a property correlates to one of those 5 senses, then it's most likely a physical property. Chemical properties, on the other hand, describe how the substance reacts with other substances. So is a substance flammable or non-flammable? Will it combust or burn? What's its flash point? That's the temperature at which a vapor from a flammable substance will ignite in air. Does it dissolve? Does it rust? Does it react in any way? Is it corrosive or does it oxidize? These are all chemical properties. And these are describing how a substance reacts with other substances. So let's do a quick concept check. So which of the following statements describes a physical property of the substance? Copper metal can be drawn into thin wires. Gold metal does not tarnish in air. Hydrogen peroxide decomposes in the presence of light, or no correct answer. So take a minute if you need to pause the video, and we'll do quite a few of these concept checks throughout this chapter as well as the subsequent chapters. And so it's a good chance. Pause the video if you need, answer the question, and then continue on once you've given yourself a chance to answer. So for this one, the answer is A. Copper metal can be drawn into thin wires. Being drawn into thin wires, that's a property called being ductile. So copper metal can be drawn into thin wires, and it's one of the main metals used in electrical systems. Tarnishing is a chemical reaction. It's like a metal being exposed to air and changing its composition on the surface that's exposed. Hydrogen peroxide decomposing. Decomposing is when one substance turns into another substance. So that's also going to be a chemical property. Let's do another one. Which of the following statements describes a chemical property of the substance? Aluminum metal is shiny. Iron oxidizes in oxygen. Ethanol melts at negative 173 degrees Celsius, or no correct response. So again, chemical properties involve how matter reacts, and physical properties involve the physical characteristics of the matter. So for this one, the answer is B. Iron oxidizes in oxygen. Oxidation is a chemical reaction. So iron, the surface of iron exposed to air, air contains oxygen. The iron and the oxygen in the air will undergo a chemical reaction to make a new chemical substance. So that's a reactive property of iron, meaning it's a chemical property. So to go along with the properties of matter, what phase is it? And describing the properties in terms of chemical and physical properties, we can also talk about how matter changes. And when matter changes, is it undergoing a physical change or a chemical change? And so a physical change kind of goes along with the physical properties. So a physical change is a process in which a substance changes in physical appearance, but it doesn't change its chemical composition. So it might change how it looks or how it feels or what state it's in, whether it's a solid, a liquid, or a gas. But at the end of a physical change, the substance still has the same identity. So in a physical change, a new substance is not formed. What you start with is what you still end up with. And so really common physical changes are changes in the physical state, like a gas converting to a liquid, if you condense water vapor, or a liquid converting to a solid, when you freeze water from a liquid into, say, solid ice cubes, or a solid converting to a liquid. Any of those phase changes are very common physical changes. In the example of freezing water to make ice, you start out with H2O molecules, water, and at the end, you still have H2O molecules. They're just in a different physical state. So that's a physical change that happened. And so through the study of matter, chemists work to understand the physical and chemical changes to bring about favorable ones and prevent undesirable ones. As chemists, we study matter and we seek to understand physical as well as chemical changes in matter so that we can get the reactions we want and avoid the ones that we don't want. So along with physical changes, the other type of change matter undergoes is a chemical change. So a chemical change is a process in which a substance undergoes a change in its chemical composition. So when something changes its chemical composition, it's going to convert the material or materials into one or more new substances. And so the properties of those new substances will be different from the properties of the original substances. So when you undergo a chemical change in matter, something new is formed. Unlike a physical change where you start out with water molecules and you freeze them, and at the end, you still have water molecules. In a chemical change, the actual chemical composition will change. So let's say you start out with water, and instead of freezing it, you separate the oxygen and the hydrogen atoms from each other. And you end up with hydrogen atoms and oxygen atoms at the end. instead of water molecules. So that's a chemical change. Chemical changes are observed when we see a chemical property. So for example, if we observe iron oxidizing in the presence of air, which contains oxygen, to make iron oxide, which is rust, that's a chemical change. And the chemical property we observed was oxidation. So you can see the changes in the properties, physical changes and physical properties kind of go hand in hand, and chemical changes and chemical properties go hand in hand. So here's a quick summary. This image is also in your textbook of the properties and changes in matter. So we have physical. So this term conveys the idea that the composition, the chemical identity of a substance does not change. You have physical properties, properties that are observable without changing the composition, like color, shape, the phase, melting point, boiling point, etc. And you have physical changes, and these are the changes that are observable without changing composition. So changing physical state, changing in the state of subdivision, for example, taking a substance and dividing it into smaller parts, but not changing the actual substance, just breaking it into smaller bits. Those are examples of physical properties. And then chemical, this term conveys the idea that the composition, the actual chemical identity of a substance does change. So again, properties and changes go hand in hand. So chemical properties describe how a substance changes or resists a change to make something new. So if something is flammable or non-flammable, if it decomposes, if it reacts with certain substances, these are all chemical properties. And the chemical change is the change in which one or more new substances are formed. So the decomposition reaction, the oxidation reaction, the combustion reaction, burning something. And so again, you'll want to be able to identify if something is a physical or a chemical property, as well as if something is a physical or a chemical change. So let's do another concept check. Which of the following processes is not a physical change? So crushing ice cubes to make ice chips, melting ice cubes to produce liquid water, freezing liquid water to produce ice cubes. So which of these is not a physical change? If it's not a physical change, it must be a chemical change. The correct answer on this one is D, no correct response. Crushing ice cubes to make ice chips is just changing the subdivision of the substance. You didn't change the chemical nature of it, it's still ice, you just broke it up into smaller pieces. Melting ice cubes to produce liquid water, you still have water as your chemical entity at the beginning and the end of this process, so it's a physical process. And then freezing liquid water to produce ice cubes, you're changing the state, the physical state of the chemical compound, but you're not changing the actual compound, it's still water. So the correct answer is D, no correct response. Another one, which of the following processes is a chemical change? Melting ice cubes to produce liquid water, gasoline burning, oil floating on water, or no correct response? The correct answer to this one is B, gasoline burning. When you burn a substance, which is called a combustion reaction, you're changing the substance. You're breaking or making chemical bonds to form a new chemical substance at the end of the reaction. So combustion, flammability, burning, those are all key words to kind of think of as examples of chemical changes.